when one inertial frame is moving relative to the other in any direction. Second case, when one inertial frame is moving relative to the other in direction, relative to the other in any direction, This is the origin O and S. This is the S, y axis, and this is the x dash axis, and this is the origin O dash, and this is the x axis, and this is the point P, the value x, y, z, T, and the next value x, y dash, z dash, t dash, point P, and this is the z axis, and this is the z dash axis, O dash point, and this is the OP, this is the O dash P dash, and this is the OP dash, this is the OP, and the vector R, the y dash, h dash, x axis, this is the point P, and this is the point, and YT, and the value of this is VYT, and this is the value, this value is VXT. Now let the frame S dash move with respect to the frame S. Now let the frame S dash move with respect to the frame S with uniform velocity vector V, given by vector V equal to Bxi plus Byj plus VZK. Then in any direction where Vx, Vy, Vz are the component of V along x, y, and z direction respectively, the origin and the axis of two frames are so chosen that each coincide at t equal to t dash equal to 0 after time t. The frame S dash is separated from the frame S by a distance Vxt and Vyt, Vxt and Vyt, and Vzt. This is the Vy Vzt. This is the Vzt. And Vzt along the xyz axis respectively. If xyz t are the coordinates of an event P, If x, y, z and t are the coordinate of an event P in the frame S, and x dash, y dash, z dash and t dash are the same event in the same S dash, then x dash equal to x minus v x t, y dash equal to y minus v y t plus, and z dash equal to z minus v z t, and t dash equal to t. Then in this case vector r1 dash, vector r1 dash equal to x minus bxt I plus y minus by t j plus z minus bz t k equal to 1 minute. Equal to xi plus yj plus zk minus bxi plus byj plus bzk into t equal to vector r minus vt, vector vt, where vector b equal to bxi plus byj plus bzk, and thus Galilean transformation can also be put as thus Galilean transformation Galilean transformation can also be put as vector r equal to vector r minus vector bt, and t dash equal to t. We shall, however, restrict our discussion to the simple case discussion in one where S dash is moving along the x-axis relative to the frame S dash. Galilean invariance. We shall it states that, and next is Galilean invariance. Galilean invariance, and next is Galilean invariance. It states that the basic law of mechanics do not change under Galilean transformation. The basic law of mechanics do not change under Galilean transformation. It states that the basic laws of motion, the basic laws of mechanics do not change under Galilean transformation. Galilean transformation. The basic laws of mechanics do not change. The basic laws of mechanics. The basic laws of mechanics do not change under Galilean transformation. Do not change under Galilean transformation. The basic laws of Newtonian mechanics are the Newton's law of motion, laws of conservation of momentum and energy etc. Will shall prove below that a space interval is invariant under Galilean transformation. Consider a rod at rest in the inertial frame S having its two ends at the point x2, x1, then the observer's S dash, the length of the rod equal to x2 minus x1, x2 minus x1. Consider a rod in the rest inertial frame. Consider a rod. Consider a rod. Consider a rod. Consider a rod at rest in the inertial frame S dash, at rest in the inertial frame S. Inertial frame S having its two ends at the point x2 and x1. x2 and x1, 2 point. Having x2 and x1, then for the observer S dash, then for the observer S. Then for the observer S, the length of the rod, the length of the rod equal to x2 minus x1, x2 minus x1. The observer S dash will consider the rod to moving with velocity minus v, with velocity minus v. The observer S dash will consider the rod to moving with velocity minus v from O dash to O, and will observe the two ends to be at the point x2 dash and x1 dash point. This is the point x1 dash at the same time. The observer S dash will consider the rod to be moving with velocity minus v from O dash to O, and will observe the two ends to be at the point x2 dash and x1 dash, at the same time. For the observer S dash, the length of the rod. For the observer S dash, the length of the rod. The length of the rod equal to x2 dash minus x1 dash, x2 dash minus x1 dash, x2 dash minus x1 dash, x2 dash minus x1 dash equal to x2 minus v2, vt2 minus x1 minus vt1 equal to x2 minus x1 minus vt2 minus t1. But the ends of the rod have been observed at one and the same time. T1 equal to T2R. T2 minus T1 equal to 0. T2 minus T1 equal to 0 is that. So x2 dash minus x1 dash equal to x2 minus x1. x2 minus x1. Relation shows that first relation. This is the first relation. Relation first shows that the space interval or the distance between 2 points is invariant under Galilean transformation. That the space interval or the distance between 2 points or length is invariant under Galilean transformation. Galilean transformation. Galilean transformation. The space interval are distance. The space interval are distance between 2 points. That means length of the rod is invariant under Galilean transformation. Thus we find the space interval measurement and time interval measurement are independent of the relative motion of the inertial frames. Classical physics already assumes that mass of a body is constant and independent of its motion with respect to an inertial frame. Thus, all the three fundamental quantities. Thus, all the three fundamental quantities length. Thus, all the three fundamental quantities length, mass and time. Length, mass and time are invariant of the relative motion. Are invariant of the relative motion of the observer. Of the relative motion of the observer. Thus, property is known as Galilean invariance. Hence, 1 minute. This property is known as 1 minute. This properties is known as Galilean transformation invariance. Hence, first number. Hence, the mass of a body is the same for all observers. The mass of a body is the same. The mass of a body is the same for all observers. And it is independent of the motion of the observer. Mass is an absolute quantity. Is that mass is an absolute quantity. Second number. The motion has no effect on time. The motion has no effect. The motion has no effect on time. If the clocks in two inner inertial frames, if the clocks in two inertial frame which are in uniform motion, which are in uniform motion, agree at the one instance, agree at one instance, they will agree at all later time. They will agree at all later times. Is that t equal to t dash. Time is an absolute quantity. Time is an absolute quantity. Absolute quantity. Time is an absolute quantity. Mass is an absolute quantity. And third number is the length of a rod does not change. The length of a rod does not change due to relative motion of an inertial frame. Due to relative motion of inertial frame with respect to another inertial frame with respect to other. The length of a rod does not change due to relative motion of a inertial frame with respect to other. Hence, space interval is an invariant quantity. Hence, space interval is an invariant quantity. Invariant quantity. In next heading, we will be study about Newton's law of motion invariant to Galilean transformation. Okay, thank you.